Transverse waves. Now, a transverse wave. A transverse wave is a wave in which the medium vibrates at right angles to the direction of its propagation. The whole point about waves is that if we make a disturbance over here, it will then transfer that energy through the particles in that medium. Now, in this case, this medium is obviously our string. Now, the whole point about the energy being transferred is that it's not that the particles move along, it's that they pass their energy along. And that is the main aim of a wave, is it transfers energy. So if we look at the animation, we can see there that as we get this thing to move, it is passing that energy through each of these particles that then move along like that. What we can see there is that particle is moving up and down, and the whole wave moves then to the right. So let's start looking at the anatomy of a wave. Firstly, we have our crests and troughs. Now, crests and troughs are simply the furthest point away from the normal position. So, what is a normal position? A normal position is the rest position or the equilibrium point of the wave, or the center point of it. We then get our crests, which are the highest point above the normal, which means that this is also a crest. And then our troughs are the lowest point. Both of these would be troughs. We then get amplitude. Now, amplitudes are the maximum distance that the wave has moved away from the normal. So that over there would be an amplitude. That as well is also an amplitude. The last thing that we get here is the wavelength. Now, wavelengths I find quite interesting because it is the distance between crest to crest or trough to trough. So that could be from crest to crest is a wavelength, and from trough to trough is also a wavelength.